Hello everyone, welcome back again. So we have been solving NJSLA Algebra 1 questions on quadratic functions and quadratic equations. So you can pause the video and you can read the question first. So here system of equations given to us. Usually in system of equation chapters we have two linear systems, so we can use elimination method, substitution method, and graphical method to solve those system of equation. Here also, when any system, we can use those methods also. Which one is easy for you, you can try it, okay? So if it is calculator question, definitely you can use your calculator and draw the graph and trace the graph, and you can find the point of intersection. Here, what it is asked. Consider the system and select the places in the coordinate plane and to plot the points. So we need to plot the points here only. We should not plot the whole graph here. We should plot the points where those two graphs are intersecting. Okay, there are two ways here to solve it, but to be sure, definitely the algebraic way is always easier. But sometimes when we are solving algebraic way, we can be a little bit confused. Okay, so 2x plus y1 is a linear equation, yeah, as you know. This is a y is equal to x squared minus 2x minus 3 is a quadratic equation or quadratic graph, quadratic function. So it is not in just slope intercept form. If you isolate y here, negative 2x, so let me try to draw the graph first, okay? So it's becoming y is equal to negative 2x plus 1. So negative 2 is the slope and plus 1 is what is y-intercept. Let's start from plus 1. And slope is negative 2 means 2 unit up and 1 unit left. 2 unit up, 1 unit left. So this is the path that your graph, your linear graph will follow, okay? This is the path your linear graph will follow. Okay, you can insert a line here which is passing through this point till this point. Okay, that is y is equal to y is equal to y is equal to that is y is equal to negative 2x plus 1 line. So where this line intersect this parabola, y is equal to x squared minus 2x minus 3. So how we can draw this parabola? This parabola is facing upward because it's plus x squared, okay? So you can find some features of this parabola. For example, x of symmetry you can find, or x-intercept you can find by factoring it, okay? So what is x of symmetry here? X of symmetry is negative b over 2a, yeah? So b is here negative 2, negative, negative 2, divided by 2 times 1. So x of symmetry is 2 over 2, which is 1. So x of symmetry is here. Let me just draw it. X of symmetry is equal to x equal to 1 line. So your parabola vertex will be on this line, okay? And it should be what? It should be symmetry according to this line. So x equal to 1 is x coordinate of the vertex. To find y coordinate, what we need to do? This one we need to plug in simply in the place of equation. Y is equal to 1 square minus 2 times 1 minus 3. Okay, 1 square 1 minus 2 times 1 is 2 minus 3. So 1 minus 2 minus 3 minus 5. 1 minus 5 is negative 4. So your vertex is 1 comma negative. Okay, 1 comma negative 4. Where is that? 1 comma negative 4 is here. So your quadratic function, since it is coefficient is 1, so at here it should be like this. Okay, then when it comes to 3, you can find when it comes to 3, it will be here. Okay, it will be here. You can find, we can plug in 3 here. 3 square is 9. 2 times 3 is 6. 6 minus 3. 9 minus 9 at 0. Here symmetry, so it should come at negative, at negative 1. Okay, at negative 1. It should be symmetry, not negative 2. So then you continue up this side. When you continue up, somewhere here, I'm not sure, somewhere here it will intersect, okay? I'm not sure, but I need to check this point also. This point is negative 2, comma 5, okay? We can find. This point is intersection 2 and negative 3, 2 and negative 3. So I need to check those points. So I'm not sure those points really correct or not. So I draw the graph roughly, okay? I draw the graph roughly negative 2 comma 5, whether they are correct or not. So if x is 2, let's check it. Y is equal to negative 2x plus 1. If x is 2, y is equal to negative 2 times 2 plus 1 is equal to what? Negative 4 plus 1, which is negative 3. So good. 2 and negative 3 is one of the point. Yep, we got it. Or if x is negative 2, check it. Y is equal to negative 2 times negative 2 plus 1. So negative 2 times negative 2 is positive 4 plus 1, which is positive 5. If x is negative 2, y is positive 5. Yeah, this is also correct. This is one way of solution that roughly we draw the graph and we got it, okay? There is another solution here, algebraically. What is that? Let me write it with blue color. So if two graphs are intersecting, means they have common points, means their x and y values must be equal. So here y is equal to negative 2x plus 1 is one of your graph. Other graph is y is equal to x squared minus 2x minus 3. So if those graphs are intersecting, their x and y values must be equal. Let's equate them. X squared minus 2x minus 3 is equal to negative 2x plus 1, okay? They must be equal. So we have a quadratic equation now. But this quadratic equation not in standard form. So let's write in standard form. Let's make this side 0, means add positive 2x and subtract 1 here, add positive 2x, subtract 1 here. This will be gone, is equal to 0. Here, x squared, oh, interesting. These are also gone. X squared minus 2x plus 2x cancel out. Negative 3, negative 1 is negative 4. X squared minus 4 is 0. We got one simple equation. Either you factor it, x squared minus 4, like x minus 2x plus 2, or take for other side, x squared is equal to 4. Which number square is 4? Since it's a quadratic equation, x should be plus minus 2 because 2 square is 4 and negative 2 square also. So x, we have two x values. X is 2 and x is negative 2, okay? And we need to check them. Already we checked them here, you see? X is equal to 2 and x is minus 2, we check them. If x is equal to 2, y is equal to negative 3. If x is equal to negative 2, y is equal to positive 5. Yeah, we checked them already. Which means at 2 and negative 3, one of the point. Other is at negative 2 and positive 5 is another point. After finding them, we don't need to draw whole graph because they say plot the points only. What we need to do here, we just erase them, okay? We just erase them. What it should come, well, what it should remain there only? What it should remain there only? So those point of intersection should remain there only because in this graph, they say that plot those points only, okay? Where they are solution. So let me plot them little bit thicker color. So this point and this point, most probably the plotting tools will be given to you. Okay. I hope you enjoyed the video. See you in the next video. Thank you for watching.